So welcome back to applications. I know it, word problems. And this is a scientific word problem. I'm reading the book The Martian, and it's just amazing the kind of math this guy's doing on Mars. So this is like child's play for him, but for me and you, I don't deal with these numbers every day. So let's see what we have here. The distance from the Sun to the Andromeda Galaxy is 1.2 times 10 to the 19th miles. If I put that in decimal notation, I don't know if I can even read that number. That's a pretty big distance. Light travels at a speed of 5.88 times 10 to the 12th miles per year. So the speed of light basically is how fast light can travel in a year, or actually this is called a light year. So light travels at a speed of 5.88 times 10 to the 12th miles per year. That's called a light year. So how long does it take light to travel from the Sun to the Andromeda Galaxy? So basically we're asking for how long. What I'm picking up on in this case, my unit of time is in years. So when it says how long, it's probably asking me how many years does it take the light from the Sun to get to the Andromeda Galaxy. So let's see how that plays out. So here's a simpler problem for us. That's not too real world for me and you, but I think you have a grasp of what 100 miles looks like. So let's say we had a distance of 100 miles to travel, and let's suppose we were going 20 miles per hour. That's our speed, 20 miles per hour. I think most of us have a better grasp of what 20 miles per hour looks like. If I was going downhill on a bike, I could probably reach 20 miles per hour. I know in a car, 20 miles per hour seems like I'm sitting still, so it's pretty slow. But traveling 100 miles in 20 miles per hour, the question is, how long would it take to travel 100 miles if I was going at a speed of 20 miles per hour? Now for me, if I wasn't really sure how to do this problem, what I could do is to start out with a table. Well, let's suppose I traveled 1 hour. I understand that in 1 hour I could go 20 miles. But my goal is to get to 100 miles. So if I travel 2 hours at 20 miles per hour, so I'm going 20 miles per hour. Oops. Got a little wet spot there. So again, 2 hours, and remember I'm going 20 miles per hour. So that means I'm going to get basically a 20 and a 20, and that's going to give me a distance of 40 miles. So if I travel 3 hours, and again if I'm going 20 miles per hour, I'm kind of seeing that would give me a distance of 60 miles. If I go 4 hours, traveling 20 miles per hour, I kind of see that I'm going 80 miles. And if I go 5 hours for 20 miles per hour, I kind of see that that's going to get me up to 100 miles. So I pick up on that 5 hours going 20 miles per hour will indeed get me up to 100 miles. So what I pick up on is, if I have a time and a rate, a speed, those together can equal my distance. So what I pick up on is my time times my speed. That's going to actually equal my distance. What I want to know though is the time in my problem. I want to know how long. So what I can pick up on is, if I want to isolate time, since speed is connected to location, I can get rid of speed by dividing by speed. And I can create a formula that says my time can be determined if I divide the distance by the speed. So if I was traveling a distance of 100 miles and I was divided by 20 miles per hour, that is going to give me a distance of, a time of 5 hours. So what I'm picking up on is, by doing a simple problem, I'm seeing that the time and the speed are are multiplied to give me the distance. But since I want to know what time is, I can kind of do some algebraic manipulations. I can isolate time by dividing by speed, because speed is connected by location. I can create a formula that says time is going to be distance divided by speed. Okay? So, that simple problem helps me see a path that we can take to solve this problem. So, I'm going to clean that up a little bit. So, by doing some simple math, looking at some stuff, I'm now picking up on that my time can be determined if I know the distance divided by the speed, or sometimes we call that the rate. A rate, a speed, or a distance. So, time can be determined if I know the distance and the rate of speed. So in our problem, we don't know what the time is, but we do know that the time, still got some wet spots here. We do know that the time can be determined by the distance over the rate. Well, we know the distance is going to be this 1.2 times 10 to the 19th. We know the speed is going to be 5.88 times 10 to the 12th. So, what I'm picking up on is, I can simplify this by, 10 to the 19th divided by 10 to the 12th. I can kind of see that's that rule of exponents. That's going to be like 10 to the 7th. So what I have is 1.2 times 5.88 times 10 to the 7th. And this is going to be in years. So, I can pick up a calculator and I can divide 1.2 by 5.88. And that's going to have to be estimated. I'm going to round this to 3 decimal places. So that's going to be 0.204 times 10 to the 7th. So that's what I have. Now, what they want me to do, though, is probably put this in scientific notation. Notice this really isn't in scientific notation. So what I probably want to do is, I want to change this to decimal notation and then flip it back into scientific notation. So remember, 10 to the 7th means to move the decimal 7 places to the right. So that's going to equal 204, and then add 4 more zeros. Yep, 4 more zeros. So what I'm picking up on, it's going to take the sun, the light from the sun, it's going to take it 2,040,000 years to get there. That is an insane number, thinking about that I'm only going to live for, hopefully, I may get to my 90s. So just think about that, how long that light's been traveling in space. Those numbers are just insane on how big they are. So, but I want to put this in scientific notation. So remember, to put it in scientific notation, I need to slide my decimal back to make a number between 1 and 10. So I got to move back 1, 2, 3, 4, 5, 6. So what I picked up on then is, I'm going to have 2.04. Keep the 4, all those other zeros you can drop out. Keep the important digits there. And since you move the decimal 6 places, that would be 2.4 times 10 to the 6th. Since I lost all those decimal places, I got to put that 10 to the 6th in there to put that balance back out. So 2.04 times 10 to the 6th, that's how many years it would take for the light to get from the sun to the Andromeda Galaxy. So I know we're the Milky Way galaxy, so I don't know where the Andromeda Galaxy is, so do some research. Stay tuned for another example.